Good morning. This week we are going to focus on the topic about the MRP, stand for Material Requirement Planning. The last week lesson we are talking about the independent demand, which is the demand that are not related to the other items. For instance, we are talking about the car, television, or ice cream. They are finished good. This product has no related to the other item, or in other words, there is no product that create the demand for this kind of item. So this is what we call independent demand. The pattern of the demand for the independent demand is normally constant. So usually the demand for the independent demand, the pattern of the demand of the independent demand is like this. This is the independent constant rate. This finished good. Okay, normally it fluctuates a little bit, but we round it up to this graph or this line. Okay, we call it constant demand. And the demand pattern that we are going to focus today is the dependent demand, which is the demand for the item is dependent on the demand for other items. Okay, normally it's finished good. So if we are talking about automobile, okay, automobile as we discussed earlier, this one is the independent demand. But if we are considering the demand for the wheel, the demand for the wheel depends on the demand for the car, right? Okay, so this will depend on the car. So this demand is the dependent demand. Okay, so for the dependent demand, normally we are talking about the raw material, components, sub-assembly, which are depend on the demand for finished good or other sub-assembly. Normally for the dependent demand often occur in a lump. Okay, here it's occur in a chunk, and then no more, and then again in lump, and then no, then the lump. Okay, so it's different from demand the finished good or independent demand, and this one is the demand for the dependent demand. This is the pattern. And in order to manage the dependent demand, we need these tools, that is material requirement planning. Before I'm going through the MRP, first you need to know about bill of material, or in industry we often say that is BOM, B-O-M, BOM. Okay, BOM represents the product structure. It is a file that indicates all raw material that are needed, or the component, sub-assembly, or assembly required to produce an item. It's show the way finished product or parent item. Okay, we have this word parent item is put together from individual item or component or sub-assembly. For instance, if we are looking at the skateboard, product 3, okay, this word product 3 and BOM is more or less the same. Bill of material or BOM is more or less the same. If you're looking at this product, okay, this product consists of, it's called sidewalk special. Okay, this one sidewalk special consists of two main components, that is fiberglass board, this fiberglass board, and wheel assembly. Okay, the number in the parentheses represent the number of the offspring that are needed to build, to create one parent item. this parent item, this offspring. So you can see here that the number one here, okay, number one here represent that one fiberglass board is need in order to produce one sidewalk special. And because two wheel assembly are needed to produce sidewalk special, so this one is 2. Okay, this number is 2. Again here, for one wheel assembly, you need 2 wheels, right? For one wheel assembly, this one wheel assembly, you need 2 wheels, 1 and 2. You need 1 spindle. Here is the spindle. You need 1 wheel mount stand. This 1 wheel mount stand underneath the fiberglass board, and 2 lock nuts, 1 here and 1 here, right? Okay, this is the way that the bill of material is represented. This is what I have already explained. Okay, so if you need 50 sidewalk special, how many board that you are required? Need this one 50? You need this one 50, right? But you need 100 of wheel assembly, okay? Because it's the relationship is 1 to 2. You need this one 50, so the wheel assembly is 100, because 50 multiplied by 2 is 100. What about wheels? Okay, the relationship between wheel assembly and wheel is 1 to 2. So in this case, if you want 50 sidewalk special, you need 100 of this. If you have 100 of this, you need 200 of wheel, 100 of spindle, 100 of wheel mount stand, and 200 of lock nuts. Alright, this is what I have already calculated for you. Okay, and normally for the item, when you place the order, there are often lead time, or what we call purchasing lead time or production lead time. It depends whether or not you produce it in-house, or you ask somebody, or you ask your supplier to produce for you. So here, the question gives you the lead time. Okay, for if you want to assemble the sidewalk special, if you got all the required component, you need 1 week. If you order fiberglass board, you need 3 weeks lead time. Okay, wheel assembly, maybe you need 1 week for production. Wheel mount stand, 4 week lead time. 1 week lead time for wheel, 1 week lead time for lock nut, and 2 weeks for spindle. Here is the what we call the time scale assembly chart for the skateboard. This we are going. If you want to prepare, you have to start from the finished good, and you go backward in times. Normally there will be minus, okay, -1, -2, -3, -4, -5, and -6. But here we omit the minus sign, okay? But you all know that this minus. In order to produce the finished good, that is the sidewalk special, right? Sidewalk special. What you need is 2 components, that is the fiberglass board and wheel mount stand. Sorry, fiberglass board and wheel assembly. So this is fiberglass board, okay, board, wheel assembly. But actually, the fiberglass board requires 3 weeks. 3 weeks, okay? Sorry. Before that, if you want to assembly all together, you need 1 week production. So, in order to get everything ready, all the component, these 2 components, that is fiberglass board and wheel assembly, must be ready at week -1, right? Okay, because you need 1 week to assembly it, to finish at week 0. right? Okay, so in this case, but the board here, we need 3 weeks, right? Okay, here 3 weeks fiberglass board, 3 weeks. 1, 2, 3. You need to order it here. And because the wheel assembly need 1 week, okay, ready here. So you back with 1 week here. Everything must be ready at the beginning of week 2, right? Week minus 2. So lock nut, wheel mount stand, and spindle, and also wheels must be ready. Everything must be ready here at the beginning of week 2. But actually for the lock nut, you need lock nut 1 week, right? Okay, so you need to backward 1 week, you need to order it here. And wheel mount stand, right? Wheel mount stand is wheel mount stand 4 week here. 1, 2, 3, and 4. You need to order here. And the wheel 1 week. Okay. Want to get it here? So backward 1 week. You have to order it here. And the last one is spindle. Spindle require 2 weeks. So spindle, you need it here. So 1, 2. So this is the picture of the time scale assembly chart for the skateboard. And the minimum production lead time is 6 weeks, meaning that you need at least 6 weeks to produce the complete set of the skateboard, right? Sidewalk special, you need at least 6 weeks. Okay, so suppose that customer order 50 sidewalk special from you, and for the simple case there is no on-hand inventory. On-hand inventory meaning that you have got some item in your stock, but the simplest way for the calculation, okay, we just assume that there is no on-hand inventory at all. So if I say that, okay, we need 50 sidewalk special, okay, and there at the beginning of week 10, right? Okay, we need 50 sidewalk special at the beginning of week 10. Now what is the quantity that you have to order and when? That is the MRP table. That is the MRP or MRP table preparation. So everything is at the beginning of weeks, right? Okay, so you need 50 sidewalk special at the beginning of week 10. As you remember, if you remember, you need 1 week lead time. So all the two components that are required to produce sidewalk special, that is board and wheel assembly, right? Board and wheel assembly, fiberglass board and wheel assembly are needed. So here, both items must be ready at the beginning of week 9. The amount that supposed to have, this is 1-to-1 relationship. So if you need this 50, you need 50 of board at the beginning of week 9, but you need 100 of wheel assembly at the beginning of week 9. 100. But for the board, it takes 3 weeks to order. So you need to order, if you want it at the beginning of week 9, you need to order it at the beginning of week 6, right? And wheel assembly need 100 here. Need 1 week assembly, so everything must be ready here. So this 100, this is 100. But for wheel assembly, you need 4 items, that is wheel, spindle, mouse stand, and lock nuts. Right? 4 items supposed to be ready at the beginning of week 8 in order to assembly together, in order to get the wheel assembly at the beginning of week 9, because it takes 1 week production or 1 week assembly. So because of the relationship between wheel assembly and wheel is 1 to 2, so this 100, this 200, 100, this 1 to 1, right? 1 to 1 and 1 to 2 for lock nuts. So for the wheel, 1 week lead time. Okay, so this, if you need it at the beginning of week 8, you need it. You need to purchase it at the beginning of week 7. Here again, if you need 100 here, you need to purchase it 100 as well at the beginning of week 6. But here you need 4 weeks, right? So if you need it at the beginning of week 8, you need to purchase it at the beginning of week 4. And this one is 1 to 1 and 1 week lead time. So you need to place order at the beginning of week 7 in the amount of 200 items. Here is the solution or the answer of the very simple one, no on-hand inventory. And if you order later than this date, it would result in late shipment. What if you order it earlier than this date? You will have more inventory than required. Okay, it's not so good. So MRP can manage the right material to go to the right place at the right time. So the process of the MRP, this is the process of the MRP. I'm not going to explain it to you by using this word because it's going to confuse you. Okay, you need to compute gross requirement, you need to subtract on hand and on order to get the net requirement and apply lot sizing rules, and then you file plan order release. So in order to do that, you need to plan for the use the table. It's much easier to do it. But for lot sizing rules, that may be applied to the MRP computation. So the first one is lot ordering, meaning that you order in the amount that you are required, no more, no less. Okay, this is lot ordering. And sometimes if you place the order and some supplier give you some minimum order quantity or MOQ. Okay, for instance, suppose they are saying that you need to order at least 100 units, even though your requirement is just 50, but they don't sell you 50, they sell you 100. So you need to order at least 100. Or sometimes they sell this item in terms of box. In one box, it may consist of a dozen or 50 unit or 100 unit, something like that. You have to order it in that kind of unit, combination of that unit. Okay, multiple of that unit. And the last one is the combination of B and C. Okay, sometimes you need to order in terms of the combination of these two, right? So now I would like to give you some example. Okay, suppose we are looking at the children's school scissor. Okay, this one very simple one, which consists of 4 items. That is 2 blade, 1 blade, 2 blade, right? And 1 screw and 1 nut. Okay, the blades are manufactured internally with 2 week lead time. Screw and nut are purchased from hardware supplier with a 1 week lead time. Okay, they give you their lead time, production lead time, and the purchasing lead time. The assembly process for the scissor takes 1 week. Construct product 3 assembly chart and prepare MRP table. If you have the order of 120 pieces in week 7, 360, in week 9, assuming that there are 360 blade, 500 screw and 100 nut currently available in the inventory, meaning that this is the on-hand item in your store. Okay, so first of all we need to draw the product tree like this one. Okay, the finished good is the scissor is at the top, and because the scissor need 2 blade, the number 2 is here, and screw, 1 screw, okay, and 1 nut. This is the product tree or BOM. And the assembly chart, okay, you need the scissor here at time 0, right? And it says that the assembly process for the scissor takes 1 week. So here, backward 1 week, everything must be ready at the beginning of week -1 if you want to get the product at the beginning of week 0. So screw, nut and blade must be ready here. And then the screw and nut need 1 week lead time. Screw and nut need 1 week lead time. So you need to order screw here, nut here. But blade need 2 weeks lead time. Okay, 2 weeks lead time here. So you need to order blade here. Right? Okay, this is the assembly chart that you need to prepare. And the minimum production lead time require 3 weeks. Okay, 3 weeks, because at least you need 3 weeks in order to produce this product. Here, okay, from the question it says that we need 120 pieces of the scissor at the beginning of week 7 and 360 at the beginning of week 9. So we need to prepare this table. You need to prepare this table. Week 7, week 9, right? Okay, scissor. You must start from the finished good. You must start from the finished good. The table must be start from the finished good. So this is the finished good table. Starting from the finished good. Finished good is the scissor, and lead time is 1 week. Production lead time is 1 week, right? The gross requirement here come from customer requirement, that is 100 at the beginning of week 7 and 360 at the beginning of week 9. And actually there is no on-hand inventory for the scissor. So the net requirement, customer order 120, you have no on hand. So the net requirement is 120. Again, 360, 0, 360. You need it when you need it. Plan order receipt. Okay, this 120, this 360, you just copy it. And then because the 1 week lead time, right? Okay, this 1 week lead time. So you need a plan order release backward 1 week. 1 week here. 120, you need it here. So everything must be ready at week 6, 120, 360 at the beginning of week 8. Please remember this one. Okay, 6, 120, 8, 360. This one will be project to the part requirement. Now, if we are talking about blade require 2 weeks lead time, right? This one you must project from week 6 and week 8. Week 6 and week 8 from the finished good. Here, week 6 and week 8. The gross requirement come from the relationship between parent and offspring, because the relationship between blade and the finished good is 2 to 1, right? Or finished good to the blade, or parent item to the offspring is 1 to 2. So if you want 120 here, you need to 250 here. Sorry, 240 here. If you want 360 here, you need 720 here, right? But it says that you got on hand for the blade of 360, so you have 360 here until here. At the beginning of week 6, you still got on hand 360, and you need 240, right? This gross requirement projected from the finished good. So you have on hand of 360, but the requirement is just 240. This is the remaining item on hand. 360 minus 240 is 120 at the beginning of week 7. Again, you don't have the requirement at the beginning of week 7, so it still remain 120 at the beginning of week 8. So at the beginning of week 8, you need 720 item of blade, but your on hand is just 120. So the net requirement is 600. 600 comes from 720 minus 120. You got 600 here. Net requirement and plan order received here. Okay, should be the same, right? Okay, this is what you need, and when you need it here, right? Okay, so 600, and the lead time is 2 weeks. So the planned order release is backward for 2 weeks. So you need to order the blade in the amount of 600 at the beginning of week 6, right? Okay, now go to screw. Okay, screw. For the screw, again, okay, the relationship between finished good and the offspring is 1:1, right? Okay, in this case, you need screw is 120 and 360, like this one, 120, 360. Week 7, week 8. On hand is 500. So in this case, 500 remain until week 6. Week 6, you need 120, but you have 500. So the remaining item is 380 at the beginning of week 7, and 380 still remain at the beginning of week 8. Again, at the beginning of week 8, your requirement is 360, but you still have on hand available of 380. So you still have the remaining item or on hand item of 20. So you don't have to purchase anything for screw, right? Okay, no need. And for the last one, that is not lead time is 1 week. Okay, lead time is 1 week. So in this case, you got on hand 100 here. At the beginning of week 6, you need 120. So and you have on hand of 100. So the net requirement is 20, right? And then because you use them all. At the beginning of week 6, your on hand inventory, so no more left in your stock, right? It's going to be 0, 0. Okay, so in this case, your gross requirement will become your net requirement. And this item, when you need it, okay, the same week, right? Okay, 20 here, 20 here, 360 here, 360 here, and the lead time is 1 week. So 1 week lead time. You need 20 backward 1 week. You need 360 backward 1 week, right? That is the MRP table for the nut. So I give you some example about the MOQ, minimum order quantity. Suppose we say that Okay, for nuts, lead time still 1 week, but they said that the MOQ for nut is 100. You cannot order less than 100. So here you can see that you have your net requirement is 20. Actually, if there is no MOQ, you need to order here 20, right? And press order here 20 at the beginning of week 5. But your supplier doesn't allow you to order just 20. The minimum order quantity is 100. So you need to order 100. So when you order 100 here, 100 will come to you here, right? But your requirement is 20. So the remaining item in your stock is going to be 80. Okay? And 80 is going to be here, right? Okay? Your requirement is 360 and you have on hand of 80. So the net requirement is 240. But as it said, your minimum order quantity is just 100, but you need more than 100, that is 240, so you can order 240. So 240 here, 240 here. This is going to be the MRP table for the nut if MOQ is imposed. Or sometimes if we say that you cannot order you have to order in a pack. A pack consists of 1 dozen item. So here, okay, your net requirement is 20. You cannot order 20. You need 2 packs, right? Okay, 2 pack is 24. You have to order 24. And then when you order 24, your requirement is just 20. The remaining item is 4. So the net requirement is just 360 minus 4 is 356. But you cannot order 356. You have to order 360. Okay? Because that is in packs. Right? Okay? 360 will be 360 and then the remaining item on hand is going to be 4. Okay? So I show you all the trick of this MRP table, and I would like you to practice one exercise. So in the exercise, we want to produce a wooden pencil which consists of 4 components, 2 wooden halves which have to assemble together, maybe using the glue. Okay, 1 half and the other half put it together with 1 graphite rod and 1 cap and 1 eraser. Okay. Okay. The demand for the wooden pencil is 100 at the beginning of week 7 to 50, week 8 150, week 9 200, week 10. The purchasing lead time for wooden half, graphite, caps and laser is 1 to 1 to respectively. The assembly lead time takes 1 week. Prepare the product 3 assembly chart MRP table for each component, assuming that lot for lot ordering is used for wooden half and graphite, MOQ of 200 for cap and a pack of 50 for eraser. Right? Okay. Hope you enjoyed the exercise. Thank you very much for your attention.